Okay, so our final formula we need to learn for trigonometry, we've had the sine rule, we have the cosine rule, and now we have the area of a triangle rule. And much like the cosine rule, I'll probably just leave you guys a link to an explanation of how this formula is derived, and I'll put that in the lesson on Classroom, and you guys can have a look at that video. I did it up for my standard maths class, so there'll be references to standard maths in there, but the fundamental content's the same. It's quite an easy formula to decipher. But today, because there's a few questions to get through in this lesson, I'm just going to get hooking straight into the lesson. So once again, we've got a situation here where we need two sides and the included angle. All right, so the situation we have in this particular question highlights that there's our side, and there's the angle in between. All right, we can't find the area without two sides and the included angle. We can, however, use some of the other trigonometric devices we've learned about already to find that included angle if we need to. Okay, but the very first one here is a rather simple one. So as with everything, I'd like you to write out the formula. So half AB sine C, where C is that included angle. So in this case, we've got a half times by 5.4 times by 3.9 times by the sine of 85 degrees. 85.1 degrees, sorry, not 85 degrees 1 minute, 85.1 degrees. So we just plug that all into the calculator. So a half times 5.4 times 3.9 times sine of 85.1. And that's going to give us 10.49. We'll go, actually it says to correct to one decimal place, so that'll be 10.5. 10.5, all lengths are in kilometres, so kilometres squared. We've found an area. Remember, it's got to be square units. Okay, in this next example, we're going to need to know the correct angle first. So we need two sides in the included angle. So the angle we're looking for is this one down here, and we don't actually know what that is. But we do, however, have an angle and its opposite side. And we also have this side over here, and we could work out that angle there. Now, if we worked out that angle there, we'd know two angles in the triangle, and we'd be able to work out the other one. So this is going to require use of the sine rule first. And the thing that I want to know, I want to put at the top left of my equation. So I want to know an angle, so I'm going to put sine A over A. I'm going to use the formula in this form. If I was looking for a distance, I'd have A on sine A, but I'm looking for an angle, so I want sine A on A. So let's start filling that in. I don't know what A is, so we'll leave that as it is. But the side opposite is 6.94, and then it's going to be over sine of 109.92 degrees over 10.47. So I multiply both sides by 6.94. And that's going to leave me with sine of A equals sine of 109.92 over 10.47 times by 6.94. And at that point, I've just got to quickly pause. Okay, so we've worked that out. We'll pop that into our calculator. And we've got a fraction with sine of 109.92 degrees over 10.47, and we're going to multiply that by 6.94. And so we're going to go with 0.623 and a whole lot of other stuff on our calculator. So A is going to equal sine to the minus 1 of 0.623 ... So once again, use that answer key. So shift sine of whatever is in the answer there will give us our angle, which will go to 2 decimal places because the other angle's to 2 decimal places. So that's 38.55. Now, at that point, we now know two of the angles, we're going to have to figure out what the angle C is. So therefore, angle C equals 180 degrees minus 109.92 minus 38.55 degrees. So I'll put that into our calculator. So 180 minus 109.92 minus 38.55. And that gets us with 31.53 degrees. All right, so now that we've done that, we can now actually use our formula, because now I have two sides and an included angle. So for there's my side, there's my other side, and there's the angle I'm looking for. So I'll do this part in a different color. We'll do this in green. So the area equals half AB sine C. So that's half times 10.47 times 6.94 times by sine of the angle we just worked out, which is 31.53 degrees. And we plug all that into our calculator. And we're going to have a half times by 10.47 times by 6.94 times by sine of 31.53. And that's going to give us 18.999. We might just call that to the nearest square centimetre. We'll call that, or square unit, we'll call that 19. It doesn't actually say, so it's going to be 19 units squared. So that's the area of that triangle. Now, the next example we have, we've got two sides and an included angle. So that looks right, but instead of having the side, we've actually been told what the area is. So we have everything we need, we just need to sort of rearrange the equation once we substitute in. So half AB sine C. So if we start substituting in, we already know what the area is. That's 128. We know it's a half times by 15 times by x times by sine of 70 degrees. So essentially what I've got is 128 equals, well, half of 15 would be 7.5. So 7.5x sine 70 degrees. Now if I divide this side by 7.5 sine 70 degrees, then that's going to cancel out with that, that's going to cancel out with that, and I'll just be left with x, but obviously whatever I do to one side, I have to do to the other. So that's how I'll do that. So I'm going to end up with, I'll switch sides here, I'll end up with x equals 128 divided by 7.5 sine 70 degrees. And I can put all of that into my calculator and I'll create a fraction. We'll just move that out of the road. 128 over 7.5 times by sine 70 degrees. And that's going to give me 18.16. Now this isn't an area, it's just, this is going to be centimetres to two decimal places, because we already knew what the area was, we were finding out what the length of that side was. So if I have two sides and they're included angle marked and I already know the area, then I can use that area to find out what either the angle is or either of those two sides are using that formula. And I've got a couple more examples here, we'll go through all of them. So find the area of the parallelogram below. Well, the area of the parallelogram really is just going to be twice the area of one of the triangles. And if I look at that triangle on that side, I've got a side, another side, and an included angle. And being a parallelogram, if I know what that triangle is worth, the other side of the triangle is going to be exactly the same. So that will get the job done. So we just use that formula, area equals half AB sine C. And so in this case, that's going to be a half of times 10 times 6 times sine of 100 degrees. So we'll plug that into our calculator. 1 over 2 times 10 times 6 times sine 100. And that gets us to 29.54. and I might just leave that as sort of 29.55 dot dot dot. So that's the area. Actually, I probably should have made that clear up here. That's the area of the triangle, and therefore area of parallelogram equals 2 by area of the triangle, which is going to be 2 times by 29.54 dot dot dot, whatever that was in the calculator. So I just pick up the calculator and I can go 2 times by the answer. That's going to give me 59.1 centimeters squared, because it's the area of the parallelogram that we found. And our final example here. Now for this one, if I find the area of this triangle here, all right, and then if I take away this little triangle here, that will give me everything I need. So for the big triangle, I've got 2 sides and the included angle. And for the little triangle, I've got 2 sides and the included angle. So I'm just going to have to work that out, and I can spell it all out in one big thing. So the area is going to be the area of big triangle minus the area of the small triangle. And so that's going to be a half AB sine C minus a half, I'll call this A1B1 sine C1. And then I just start substituting in. So it's going to be a half of 22 times 18 times sine of 58 degrees minus a half times 12 times 8, that's our distances on the small one, times by sine of 116 degrees. So just to make that absolutely clear, there's our big triangle right there, and there's our small triangle right there. So we're just going to work out the, oh yeah, that's the colours I've used for the highlighting. So what we've ended up with is we'll work out the area of that big triangle, take away from the small triangle, but we can do that in the calculator in one little go rather than having to break it all up. So 1 over 2 times 22 times 18 times sine of 58. Close our brackets, very important there. Take away a half times, we'll go this side, 12 times 8 times by sine of 116 degrees. We close our brackets there. And that's going to leave me with 124 point, well, we'll go to 77. Go to 2 decimal places. And the units are kilometres, so that's going to be in kilometres squared. Okay? So that's the end of that. As I said, there's a video that I'll link in this lesson which allows you to see the way that this formula from the very top up here is derived. But much like the other formulas, the sine rule, the cosine rule, and the area of a triangle rule, what I really want you to be good at is diagnosing with those. Those formulas are generally given in exams, so you don't have to remember them. What you do have to do is remember, one, when to use each formula. That's really important. And the second thing that's really important is once you know you've got to use that formula, it usually is the C in the formula that's important. So making sure you get the right number in the right spot is very important with those. Okay, so practice when you're doing them, just thinking about it, taking the time and identifying where your 2 sides in the included angle are. And if you get one wrong, chances are you've messed up on that style of thing, and do it again and make sure you check that you can get the right answer out. And that'll do us for this, which is the last lesson of this week.